Swayam Prabha. Digital India. Educated India.
Okay. So with regard to solutions in this week's lab, thank you. What do you say? Would you want to show a center line over here or not? Yes sir, no sir, why not sir? Yes or no? So those who are yes and those who are convinced, raise your hands. Those who are no and those who are convinced, raise your hands. The number of hands do not match the decibel level of yes and no. Okay. Maybe it'll be a nice idea to show the center line over here. Maybe. Because if you do not show the center line there, then if you look at the top, it gives the impression that you have a rectangular slot or trapezoidal slot in there if you don't show the center line. Okay? So that's one thing. Corrected figure from last lecture. So one of the ribs is smaller in dimension, and then you see the fourth circle at the center. Okay? We'll start afresh with perspective views. Those are again a kind of pictorial views. Those who are into art will love the next 3 lectures, and those who are not into art will become artists if you follow this. Okay? What? Those who are into art will like these 3 lectures, including today's, and those who are not into art will become artists, hopefully. Okay? Okay, stay with me. Some examples. Spare your wow for some time. Some examples. What do you reckon? Are these lines parallel to each other? Are these lines parallel to each other? Yes sir, no sir? Yes? No? They are parallel to each other, but you get the impression by looking at this picture that they tend to converge to a single point. They tend to converge. Okay? Okay? Are these lines parallel to each other? Again, you get the same impression that they tend to converge. Okay? This is art. Look at those rods on the roof. Are these parallel to each other? But the impression that you get is, I'll tell you a little story about this. I'll tell you a little story about this. This is something that I worked on back in 1995, when many of you guys were probably 1-year-old toddlers, essentially, or may not have been born. Okay? Then I did not know how to draw a perspective view, frankly. I did not know how to draw a perspective view. So this was just out of intuition. Okay? Okay? Can you spot me? Leftmost? Okay. So but I do not want you guys to have the same feeling. So if you want to attempt something like this, I would want to make sure that you guys know how to draw perspective views. Okay? This is a different example. Yet another example. Let's go back to the first example. Look at these parallel lines. They tend to converge to a single point. Choose a line, they tend to converge to a single point. Fine? This example. Choose a line, again, the same thing. Again, the same thing. Here, the story is a little different. Okay? Focus on the lines on the right of this vertical edge. Okay? Focus on the lines on the right of this edge, and any line you choose and you extend, they tend to converge to a point on the right. Likewise, lines on the left of that edge, any line you choose tend to converge to the point or to a point on the left. What is interesting is that this point here and that point over there, they happen to lie on a horizontal. That's what's interesting. Okay? I call the point on the left as the vanishing point where all the edges tend to converge. Point on the right as another vanishing point. I call the horizontal line as the horizon line of horizon, and it is this line that separates the sky from the ground. Okay? Something very similar. Look at the edges on the right of this vertical edge. Okay? And the edges on the left of that vertical edge, they tend to converge to two different respective points which lie on the horizontal. Again, the points are VP1 and VP2, vanishing point 1 and vanishing point 2. The line in red is the horizon line that separates the sky from the ground. Okay? In this case, you have a single vanishing point. Single point where all lines, they tend to converge. Okay, lies on the horizontal, which separates the sky from the ground. And this point here, I call it VP1. This is again a horizon line. Okay? Okay? this is where possibly you are stationed as an observer, and I call that, or I call your position as the station point. Okay? Now let's try to apply those rules in perspective projections, apply those observations in perspective projections. Of course, you know about views: front view, top view, profile view. Okay, so this would what be the scenario in top view. Let's say you've got a picture plane. Just behind it, let's say you have a cube placed in the top view again. Okay, this is where you are stationed. Mind you, we are working with top view, so this is where you are stationed. So imagine if a bird is looking at you as well as the object over there. Okay, so this is what the bird is going to be observing, that you are looking at 4 vertices of the object like this. So those rays from the vertices will hit your eye in these directions from the top. Okay? So in a sense, you happen to get the sight information from the top view. Once again, you happen to get the sight information from the top view. Okay? Okay? Now let's switch back to the front view or the profile view. I'm standing on some line, or you are standing on some line, that's called the ground line, reference line. Okay, let's imagine that the object is on the same line as where I'm standing, and of course this is the true height of the object. Now notice something important, that this point over there is the station point, which actually belongs to top view, not the front view, but the top view. Okay, in a sense, in the front view, you will be stationed here on the ground line. Okay, so this guy belongs to the top view. That's something that you need to keep in mind. Okay, get the height. In the front view, what would be the horizon line for me? What would be the line of horizon for me in the front view? I'm standing here, this is my ground line. Okay? The line that separates the sky from the ground, where would that be? Would that be below my eye, above my eye, or at the level of my eye? Level of my eye. Okay? So in the front view, my eye will be here on this line, right above the station point. Okay? And if I look very far off, I'll be seeing the vanishing points on this line, the left or on the right. Any vanishing point has to be on the horizon line. In the front view or the profile view, you get the height information. Okay? Now what you want to do is you would want to combine both views together. Okay? So you have components from the top view, the object in the top view, the picture plane. This belongs to the profile view or the front view, ground line to the profile view or the front view. This station point belongs to the top view. So what you have done is you have combined informations from both views and placed them together. Okay? Now stay with me here. If I look at an object very far away, in the front view, if I look at an object very far away, parallel to this edge, okay, where would my vanishing point be? Once again, if I look at an object very far away from me, but along this direction, where would my vanishing point be? Where would that be? Huh? Bottom right. I'm looking straight. I'm looking straight and parallel to maybe one of those edges. Of course, my vanishing point will be on the horizon line and along this direction, which is going to be where? Here? Yeah? That is my vanishing point. Okay? So to draw a perspective, in summary, you have to identify the picture plane. Okay? You have to identify how the object is placed with respect to the picture plane. Okay? Where you are stationed in the top view. In the front view, you have to identify the ground line. You have to get the profile view of the object. You have to identify the horizon line, and you have to identify either 1 or 2 or 3 vanishing points. Okay? So once you have done that, you are ready to draw a perspective view. Okay? Let's see how. One thing that I would want to tell you is whatever feature is there on the picture plane will appear in true dimensions in your perspective view. Okay, for example, this face of, let's say, a cube is right on the projection plane of the picture plane, so that will appear in true dimensions. That is something that you need to keep in mind. Okay? Okay. Draw 2 projections vertically downward, get the height, and this is what you will see in your perspective view. Okay? This face, front view, like so. Okay? Now things become a little interesting. If you look at this edge, where would it vanish? Where would it vanish? If you look at this edge, the corresponding image in the perspective view would be like so. If you look at an edge far away, if you look at an object far away along this edge, that would be vanishing over here. Okay? Likewise, if you look at this edge, it will start from here, and objects far away along this edge, that will be vanishing, or they will be vanishing there. Okay? If you look at the bottom edge, if you start from here, if you look at the bottom edge below this, that will be vanishing again along this direction. Okay, so in a sense, what you have done is you have identified the 3 directions along which the edges are going to be vanishing, or the objects are going to be vanishing along those edges. Okay? Now, follow this very carefully. In the top view, this is what my sight ray is that allows me to see that vertex. Okay? This ray intersects the projection plane or the picture plane here. I take the vertical projection to get the corresponding image of that intersection in the front view. Okay? So the corresponding image of this vertex on this edge, on the top edge of the cube, will be here. Okay? Likewise, if I look at this vertex here, this ray intersects the picture plane over here at this point. I draw the vertical projection Okay, and this is the corresponding image of that vertex in the perspective view. Okay, what is this edge? The back edge, this edge, the edge on the left, this one, the edge on the right, but on the top face. Nah? This guy here, the bottom edge, the edge on the right but corresponding to the bottom face, and this. Okay? Yeah?
We don't need the second point after getting the first point.
So I'll tell you about that. So this is a 1 point perspective. So I'll tell you about 2 points and 3 points maybe later. So what I've drawn is a single point perspective. By that I mean that you have a single vanishing point. Okay? And to draw that, you have to keep two things in mind. Okay? Number one, that at least one face of the object that should be coincident with the picture plane or the projection plane. Not a vertex, but a single line or single face in the top view. Okay? And of course, you have to have one vanishing point. So if you're here and if you look at the object along one of the lines which is perpendicular to this, perpendicular to the projection plane, that ray is going to be hitting the horizon line over here. That would be your vanishing point, single vanishing point. Okay? Yeah? Yeah? How do you take the stationary point? That's a choice. For example, I am stationed here, I am looking at the entire class. Okay, I'll get one view. Okay, I am stationed at a different position now. I am looking at again the entire class. I'll get a slightly different view. Okay, and if I get stationed here, I'll get a different view. And don't ask me to go out. Okay, so station point is like a parameter. So it's usually specified. Okay, in other words, it's a choice. Should I go over this once again? Start with a blank sheet. Stay with me and be alert. Start with a blank sheet. Yeah?
What exactly is the smaller square over?
Don't worry about that. Maybe it'll be a nice idea for you to work this out on your sketch planes or sketchbooks while I'm going through this once again. Yeah.
That one is the top one.
That's the top view. This is the profile view. Profile view of the front view, because the height is going to be the same in both. Yeah.
So we will use the projections to draw the missing front view. We will basically use the projections to draw the missing front view.
Missing?
Third view, I mean, we've been given the front and the top view.
This is a pictorial view that you are drawing. This is something very similar to isometric view that you are drawing. Pictorial view, just single view. Okay? So given all these parameters, how would the object look like to you in 3 dimensions?
Am I not missing one?
Are you not missing one?
Effectively, I'm missing the third.
No, you just need the site information from the top view and the height information from the profile view. So essentially you have, you get the 3 coordinates. Okay, ready? Ready? Here we go. Start with the picture plane, PP. Okay, place the cube in top view in such a way that one of the edges is lying over the picture plane. It's coincident with the picture plane. Okay. Step 1, step 2, figure out where you're stationed in the top view. Just choose any random point. Okay. Step 3, in the front view or the profile view, choose the ground line. It could be either above the station point or below the station point. Doesn't really matter. For now, let's say it's above the station point. So once again, the station point is the one that you see in the top view. So keep that in mind. Okay. Draw the profile view of the object on the ground line, a single cube. Figure out what your height is, 5'6", 5'7", 5'8". If you're standing here, okay, this is where your horizon line should be, the line of the eye. Okay. Once you have the horizon line, you are ready to start making the perspective view. Once again, keep in mind that any feature of the object in top view that is lying on the picture plane will appear in true dimension in the perspective view. Keep that in mind. Okay? Yeah? What is your height? What is your height? 6'2"? Sure? Okay. So if you're stationed here and if you're not scaling your height, your horizon is going to be 6'2" minus whatever your dimension, whatever this dimension is. Okay? All right. Let's draw the front face because we know that's going to be in true dimensions. That's the vanishing point. Once again, if you look at an object far away along this direction, okay? So this ray, which is parallel to this edge over here of the object, will be hitting the horizon line over here, and that will become your vanishing point. Okay? All right, so get the true shape. Stay with me. Stay with me. Get this face in true shape. Extend a ray from this vertex towards the vanishing point. Extend another ray from this vertex towards the vanishing point. The third ray from this vertex towards the vanishing point. So in a sense, the 3 edges of this cube are going to be vanishing along these directions, and they are going to be converging towards this vanishing point. Okay? Let's use the site information. Look at the vertex in top left in top view. This ray is going to be intersecting the picture plane over here. Take the projection of this intersection on this edge. So this is the image of this vertex in the perspective view. Likewise, the vertex on top right. Okay, this ray intersects the picture plane here. Get the projection of this. This point is the image of this vertex in the perspective view, and this point is the image of that vertex on the bottom edge of the cube. Okay, and finish the cube. Let's say you have another cube. Okay, let's say you have another cube. Mishraji. Do you need some water? Double up, double up. You know, it's not your fault. It's not your fault. I must be. Reminds me of my CS 101 days when I was taking the first year course in computer science. I was taking this course on CS 101. I guess I was being taught Fortran by Professor D.M. Dhamdere. And it was not a very nice day. Quite hot, and we were actually sitting in the PC Saxena auditorium. We have this nice auditorium in there, and I was in the second bench. And usually that has never happened with me except for that one incident where my eyes felt heavy and I was like. And when the class was over, and you know, Professor D.M. Dhamdere was just here and he could have a very nice view of me, and I was like. And after the class ended, I was still like this, and when somebody did this to me, I woke up and I felt the stare. So it happens. So I don't blame you guys. Okay. All right. So imagine that we have another cube. Imagine that we have another cube of which the face is slightly behind the picture plane. Not on the picture plane, but slightly behind the picture plane. Okay? What do you do? How do you get the height information? Huh? Right. So what you do is project that face or the edge on the picture plane. You know that that will be in 2 dimensions. Okay? You see that profile view on the right. Get that face in 2 dimensions. Okay? Let the 3 edges of this cube vanish and converge at VP. Okay? Use the site information. Use the site information. This guy intersects over here. Take the projection down. That would be hitting one of those edges over there. Likewise, use the site information. See this vertex from the station point. Get the intersection point. Project that downward. And that would be hitting over here. Okay? And this face would actually be your perspective face corresponding to that object. Okay? Once again. If the features of an object are not on the picture plane, to get the height information, project the feature of the object on the picture plane, like so. You know that this face is going to be in true shape. It's going to be having 2 dimensions. Okay? Get the verticals down, get the height information from the right, draw that face in 2 dimensions. Okay? Draw this face in 2 dimensions. Let the 3 edges of that cube vanish at the vanishing point or towards the vanishing point. Okay? You would know that these two vertices, they will have to lie on these two rays. Okay? Once you know that, start working with the sight information. Use the top view, look at this vertex. This ray is going to be hitting the picture plane over here. Take that projection, come down. This is the image, this point is the image of this vertex here. Likewise, look at this vertex, get the intersection point, take the projection downward. This point is the image of this point in the perspective. Once you have this point, you would have the corresponding points on the bottom two edges. You complete the face. Yeah?
We can draw one face by using only one line from the straight line. While we can draw projection. From one projection we will get one line. Taking parallel line. We can draw the face.
We can? Fine. Stay with me. Stay with me. And the rest is straightforward. Rest is straightforward. Look at that vertex on the left. Okay. Get its projection down. Look at this vertex on the left. Get the intersection point. Get its projection down. And complete this cube like this. Okay? Straightforward. Once you understand how to construct, straightforward. It's not very difficult. Another example. So this is how the perspective of this cube looks. This is how the perspective of that cube looks. And if you observe, all these edges, they tend to converge to a single vanishing point there. Okay, how about on the right? A cube a little far away from the projection plane. Do the same thing. Project one of the faces onto the picture plane. Get the true face of this cube. Draw edges that converge towards the vanishing point. Okay. Use the sight information, project the intersection points, get the perspective of the face, of this face of the cube, and follow the same procedure and finish the cube. Art is boring, isn't it? Huh? Or maybe not. So once you practice, you'll probably get a little more excited. Okay? Questions? Questions? How many of you guys are with me? Okay, it's pretty nice. Okay, so let's draw a table. Let's draw a table in one point perspective. Okay, the top view is given, the profile view is given. Stay with me. Stay with me. And some dimensions are given. So don't worry about the dimensions. Okay. Once you have this information, let's start. I would just want you to observe. I'll go mute. I just want you guys to observe. Okay, I'll go slow. Shall I? May I? Here you go. Before I go mute, I'll also explain why this is the vanishing point. Again, if I'm stationed over here, and if I'm looking at an object far away along this direction, okay, so this point would be my vanishing point on the horizon line, and this ray from the station point, that's again top view, okay, will be parallel to that edge of the object. Single point perspective of a table. Here you go. Keep your eyes on the screen. Here you go, once again. Come after the midterm exam. Is this hard? Not yet? Not yet? But is this going? Is this giving you a realistic view of a table? This is not isometric, definitely. Are you getting a realistic view of the? Yeah? Okay. So just follow those little guidelines to draw a single point perspective view. Okay, and practice in your hostel rooms. Before you leave, wait. Before you leave, in a single point perspective, of course you have a single vanishing point. Okay? Make sure that you have at least one face of the object parallel to the projection plane. Okay? One face of the object parallel to the projection plane in the top view. Otherwise you won't get it right. So this guy has to be parallel to the projection plane of the picture plane. Okay? So if you have questions, I'm here. Otherwise,